Okay, I wanted to make a quick video here to talk about how you can solve problems numerically in Excel using the solver tool. So I came up with this example of a sort of problem that cannot be solved analytically. So if I say analytically, what I mean is there's like no way you can separate x out of this equation. This is a pretty simple expression, but there's no way you can get x by itself here. If you take the log, if you move things over, divide, there's nothing you can do to get this x and that x and put them together. So if you wanted to find the solution to this, it's something that you can't do analytically, but you can do it numerically. All right, and so before we talk about how you would do it numerically, I wanted to look at this equation just a little bit. So we'll start by making a graph. I want to make a graph here of the left side, x plus 2, and the graph of the right side. And that will kind of give us an idea of where the solution or solutions, if there's more than one, would be, the points where they intersect. So I'm going to make a little table here. I'm going to have x, I'm going to have left-hand side, I'm going to have right-hand side, and I'm going to make this between x is -3, and then I'm going to go up by 0.5 for x here, so equals the one above it, plus 0.5, and then I can drag and copy that down. So I'll just go ahead and do that here. So we'll go down, up through, right there should give me to 3, okay. And then coming back to the top, and now the left-hand side, it's going to be x plus 2, so I want it to be equals to the cell on its left, plus 2, and if I copy that down, it will populate all those cells below. And then for the right one, we want to do equals exp, e to the x is exp. It's a function, so we select the cell and then we close it, the parentheses. And now I can select those two, and if I go here and double click on this little cross, it will fill that in all the way down to the bottom. So you can see e to the x here starts getting really big at a value even of 3, and it's going to go up super fast. But let me grab all these values right quick. I'm going to use a little trick here to grab all that and make a plot really quickly. So I'm going to hit Control Shift from the upper left corner and then push right and down on the keypad, and that will allow me to select everything. And I'm going to hit Insert. I'm going to go up here and make a scatter plot, and then I'm going to put in a curvy one here. Okay, and I'm going to very quickly, I'm going to zoom out just a little bit here so we can see the chart better. And then I'm going to format this chart just a touch. So let's make the scale here between -3 and +3 for x. And then I want the y-axis here. You see it goes through at 0, and I want it to be over here. So I can change that by vertical axis crosses at an axis value of -3. So that moved that over. And then I want the y scale. Let's make that between. So if you just double click on it here, I should be able to find the settings. Yeah, so it's right now it's -5. Let's make that 0 up to 5. All right. Okay, so now you can see, I'll delete that, but you can see x going from -3 to +3. We can see e to the x here, and we can see x plus 2. And so what this shows us is that there's two solutions to this. Again, there's no way we can solve this analytically. We can't get x equals even some weird expression like pi or e or ln or something. It's just some value here, but we can see that it's a little bit less than -2 and a little bit bigger than 1. Both of those points that the graphs cross each other. So it's like, how could we find this exactly? And of course, we could just kind of guess if we were doing a rough estimate, but Excel has this tool called Solver that we can use to figure out what that is to a very precise numerical value. So let's look at how you would do that in Solver. Okay, so let's start by just trying to find the positive value here. So often when you have problems that have multiple solutions, you'll only be interested in the positive one. The other one might not have any real meaning. So let's look for that one first. Okay, and so what I'm going to do is I'm going to zoom back in here just a little bit so you can see better, and I'm going to just move that graph down for now. All right, so I'm going to set up a couple of cells here. I'm going to work in kind of right here. Let's call this solver, and so I'm going to need 4 cells to do this. I'm going to move that down just a touch. So we'll have X, and we'll have left-hand side, we'll have right-hand side, and then we'll have what I'm going to call closure. Okay. So what I want to do here basically is I'm going to guess a value for X. So we said if we look down here at this graph, X is about equal to, it looks like it's about 1.1 is about the value. So let's just kind of use that as a starting guess. X is 1.1. The left-hand side is going to be X plus 2, and the right-hand side is going to be EXPX. And then our closure condition is going to be basically we want these two to be equal. So what I need to do to use solver is I've got to find a cell that I can use to determine whether I have picked the right value for X. And so what I can do is I can say that the left-hand side minus the right-hand side needs to be 0. So as you can see here, we're not quite there. This is not exactly 0. If I make X equal to 1.2, then you can see that it jumps to negative. That means that the solution's between 1 and 1.2. So I could sit here and change this X over and over again by hand until this is 0, but that's, not using the power of the computer. So the way that solver basically is a tool that lets us take a cell and either set it equal to a value, make a min or max out of that cell. So if you're trying to do something with costs, then you might want to minimize the total cost, or if you're trying to get revenue, you might want to maximize that, or whatever it is you need to do. Here, what we want to do is change this cell until that one is 0 for this example. So you may not have the solver tool. If you have solver, if you go up here to the data ribbon in Excel in the latest version, if you have an older version of Excel, it might be in a different place, but for the more recent ones, it's under the data ribbon. You can see here under this analyze one, there's solver, and you can click that, and that brings up this solver dialog box, which I'm going to close. Okay, now if you don't see that there, you can install it really quickly by hitting File and then going down here to Options. Brings up this box, which is sort of cut off in the screen here. Let me do that, and then over here it says add-ins. Okay, and then you can see here this solver add-in. This is one that you can get, and if it's not highlighted, you can add it by going to Manage, you hit Go, and then click this box right here. This is the solver add-in, and click OK. And so we've already got it on this computer, but it won't come by default typically in Excel. So if you don't see it, that's what you need to do. Okay, so how do we use it? Again, what we want to do is we're going to change this cell to make that one equal to 0. So let's hit solver, and so it brings up this little solver dialog box. Looks like this gets a little bit cut off, but so we're just going to be worried about the top part here for now. So this says set the objective function. So what our objective function is that closure condition, and what we want to do is we want to grab this cell. Okay, so this little button allows me to click on the cell I want, and it'll grab that for me. And then we're going to set it equal to a value of 0. You could also make it a min or a max. Here we want to set it to 0, and we want it to change this cell right here. Okay. You can pick more than one cell, but the chances of something going wrong or of multiple solutions increases a lot when you have it look at changing more than one value. So it's best if you can figure out a way to make one variable cell and have one optimization cell. And so really, once you've done that, there's a button down here at the bottom you hit to solve, and then this little dialog box will come up, and it says here that it found the solution. And you can see 1.146. Now, remember that this has two solutions. Okay, so the way it works is Excel is an algorithm it uses to find this, and it's going to start wherever you are at and try to look from there. So since we started near that positive value, it found it. Now let's say that we wanted to find the negative one. We said that that's about negative 1.9 maybe. So let's try that, negative 1.9. And if I hit solver, and everything's already set up, so I can just go ahead and do it. It says solver found a solution, and well, for this example it did, but there's a little box down here that is often checked, and it says make unconstrained variables non-negative. And if that one is checked and you try to solve it, then it's going to give you an error message like this. And so that's because couldn't find anything from that starting point. It couldn't even find the positive solution. So if you want the negative one, you've got to remember that. Oftentimes we want to look within a range. So if you had a function that had a lot of zeros and you wanted to find a certain one, you may want to use a constraint. So an alternative way of telling it to look in that range is to add a constraint to the condition. And so I can do that by hitting this add button. And so what we want to do is here we're going to say basically, I'm going to grab this cell right here, and I want to say that that cell needs to be less than or equal to a value of negative 1.5 if we wanted to look for the one that we know is near negative 1.9, and add that. And then we can add another constraint here. We're going to make x, once again, x equal to negative 2.5. And note, you don't have to have just one cell here. You might have other calculated cells that you could use that could be valuable. So we'll hit OK, and so it's added both of the constraints you can see there. And even with this make unconstrained variables non-negative, I think it will still solve it. Well, yeah, it's because we started at that huge number. Let me make it negative 2, and let's try that once more. And so it says that well, we ran into trouble here again because this, the second one here, sorry, we need to fix this. So let me just change it. It needs to be bigger than negative 2.5. Okay. Yeah, so less than negative 1.5, bigger than 2.5, and solve. Okay, so now it found this negative 1.84. So this kind of gives you an introduction to how to use Solver, and you can use this for really complicated equations. You can use it for more than one variable cell that you're working with. The key thing is to remember that you want a cell that's going to change, that's going to be your variable, and then you want your closure condition that you're working with. And the connection between these two, it can be a long path with lots of cells, but it can also, here this is a relatively simple one, but this is one example of how you could use Excel.